So welcome to the final presentation of the group Noffence. Today, my partner Ifan and I will be presenting. So what do we do? The goal of our project is to create a model that detects any toxic tweets. And also the actually challenge is to distinguish the hate speeches from the offensive languages. Why this is important? Because Twitter is a big company operating around the world, so any speech will spread immediately across the community. In Canada, hate is considered as a crime. Our primary dataset has about 25,000 tweets, but as you can see, the distribution is extremely imbalanced. We initially just undersampled the class 1 and 2. Unlike the published official documents, tweets often contains much more than what we want. We are doing the preparing data, just deleting the things we don't want. Those cannot be tokenized, while keeping the valuable information as much as possible. But we still have some problems by now. After implementing a few models, we find it necessary acquiring more data. So we introduced the two additional data sets. We selected the definite hate speeches from the dataset 2, and we take just a small fraction of the positive speeches from dataset 3. In terms of balance and convenience, we just sample 10,000 rows from each of the class. Vectorization, we believe, is also an important step of data processing. In the past, people perform bag of words, which is easy and flexible to create your own vocabulary, but the limitation is also obvious, which is pretty much why coming up with the word embeddings. We followed the previous work, create the baseline using logistic regressions and SVM. We find them impressive. We also made a multi-layer perceptron with word embeddings. Besides, we constructed the convolutional neural network, which shows a remarkably progress than the MLP, but we also saw its limitation. Then we make a transformer, which is a GPT-2 to work, but actually we were struggling tuning it. It acts very unstable, and we can hardly make any improvement on its classification head.
We then built several models based on BERT. Basically, there are three parts of our full model. Firstly, the vectorized text data is fed into our pre-trained BERT layer to obtain the semantic information. After that, a hidden layer is defined to further extract the context information from the data. And after that, we designed three options for this hidden layer. The first option is using a simple MLP, while the second option we chose is bidirectional GRU, as it is good of capturing sequential information from both directions. The third option is a CNN hidden layer. It can capture the spatial relationship through a sliding window to understand the meaning of a sentence. Finally, MLP classifier and softmax function are used to get the classification labels. Next, please. The experiment results of our 8 models are shown on this table. We decide to measure the model performance using the final accuracy and the F1 score of 3 different classes. As you can see, the BERT class CNN has the best performance over all different metrics. The second best model is BERT plus by GRU, following by SVM and logistic regression. It is interesting and surprising that these two baseline models had better performance than CNN, GPT-2, and BERT base, and we will talk about this later in our discussion section. Next, please. We use the BERT plus CNN model as our best model, and here are some sample predictions of our 3 different classes. As you can see, these samples are correctly classified. Next, please. For the discussion section, first we will compare the machine learning baseline model versus our best model. Their accuracy performance are very close, 91% versus 93%. According to the confusion matrix, we can see that BERT plus CNN is slightly better in distinguishing the hate and offensive speech. And we guess there are three possible reasons for this surprising result. The first reason might be that we only have limited data volume, and we speculate that we might need more data to fine-tune the BERT architecture on this specific task. And the second reason is that the hate speech and offensive language on Twitter has a huge amount of out-of-vocabulary tokens, which could affect the model's performance as well. And the last reason we came up with is that those baseline models have stronger initial assumptions about the data, which is called inductive bias in machine learning. In comparison, deep learning architecture are more data-driven, which could explain why machine learning baselines have more comparable results than our deep learning models for this task. And finally, what would we do differently in a similar project is that we would apply for Twitter developer account with sufficient privilege earlier to get more training data, and we may think about training our vectorizer if we have enough GPU. That's all of our presentation. Thank you for listening. Do you have any questions?